This is the planet Venus, the second planet from the Sun and the closest in terms of size to our home, the Earth. That's where the similarities end though, and in this video we'll take a closer look at what we know about Venus. As I mentioned a moment ago, Venus is the second closest planet to the Sun. It orbits at an average distance of around 108 million kilometres. This means that one full year on Venus is 224 Earth days long. As before, I'll be using metric measurements in this video and putting the conversions to imperial and scientific units on screen. In terms of size, Venus is only very slightly smaller than the Earth, with a diameter of 12,103 kilometres. The Earth is approximately 12,800 kilometres for comparison. As with the closest planet to the Sun, Venus has no moons, but it does have an incredibly dense atmosphere. You'll notice any pictures you've seen so far have not really featured much in the way of surface details. Venus is on the inner edge of the so-called Goldilocks zone, where temperatures from the Sun should be suitable for water to exist in its liquid form. This is not the case, however. That same thick atmosphere that prevents us from seeing the surface of Venus leads to very high temperatures and high surface pressures. The atmospheric pressure at the surface of Venus is almost 100 times greater than on Earth, and the average temperature is 462 degrees Celsius. This is actually hotter than on the innermost planet, Mercury, and entirely due to the thick atmosphere acting like a blanket and trapping heat in. Venus spins slowly around its axis, and unlike most other planets, it rotates clockwise when viewed from above, looking down from the North Pole. What this means for Venus is that we have some strange numbers for the time taken to complete one day. Firstly, we have the astronomical concept of a sidereal day. Put simply, this is the time taken for a body to rotate one full rotation when using the stars as a fixed point in the sky. In this regard, one day on Venus lasts 243 Earth days. Venus's slow rotation, however, means that it also experiences solar days. The easiest way to imagine this is the time taken between sunrise and the next sunrise. This gives us a figure of 116 Earth days between sunrises. So far, the pictures we have seen have been mostly of a cloud-covered planet devoid of many features. We do, however, have radar-interpreted pictures of the surface. And what we see are great mountain ranges, evidence of past volcanic activity, and a thoroughly alien landscape. Being almost the same size as Earth also means Venus has almost the same gravity as Earth, coming in at around 0.9 Gs. Remember, 1 G is what you're experiencing right now, so if you could survive on the surface, and we ignore the crushing pressure and the burning hot temperature for a moment, things would feel much the same as they do now. As with all of the inner planets, it is likely that humans have known of Venus for a very long time. Again, our first record of Venus's existence can be found in those same ancient Babylonian tablets from nearly 3,500 years ago that I mentioned in the Mercury video. Many ancient cultures associated the wandering stars with their gods, and the planet Venus was named for the Roman goddess of love. Venus is one of the most obvious planets to spot in the night sky, appearing soon after sunset or just before sunrise, depending on its position relative to the Earth. Venus has popularly been known as either the morning star or the evening star because of this. It's often the brightest star in the night sky. In fact, in terms of the night sky, only a full moon can really be brighter than Venus. Unlike Mercury, Venus has been the subject of quite a few attempted flybys, orbiters and landers. To date, somewhere in the region of 42 specific robotic missions have been sent to study Venus. The majority of these missions have been launched by NASA and the Soviet Union, whereas in recent years Venus has been the subject of interest for missions launched by the European Space Agency and the Japanese Aerospace Exploration Agency. Unlike Mercury, the featureless images of Venus, showing only clouds that we can capture from afar, led to much speculation about the surface. Some even speculated that life could exist in lush tropical rainforests hidden from view by the cloud layer. This idea was immediately quashed by the first successful mission to reach Venus, Mariner 2, launched by NASA in 1962. Data from the mission indicated the presence of an extremely hot surface. A string of mission failures followed until the next successful mission, a lander mission called Venera 4, launched by the Soviet Union in 1967. Venera 4 would become the first man-made object to successfully return data from in-situ analysis of another planet. What that means is that it was actually physically sampling the material that it was investigating. Flyby missions and orbiter missions gather their data from a distance. We interpret the data that we're getting. We don't directly sample what we're looking at with orbiters. What Venera 4 found was an extremely hot planet with an atmosphere made up almost entirely of carbon dioxide. And this is where Venus's high temperatures come from. Carbon dioxide is a greenhouse gas that prevents that heat from easily escaping. Although Venera 4 probably did make it to the surface, it had not been designed to survive in the extreme conditions that it found. And it would be a number of years until the Soviet Venera 7 was launched in 1970 before a probe achieved a successful landing on Venus. Venusian exploration has not been limited to the Soviet Union, of course. NASA had a number of missions in its Magellan and Pioneer series to study the planet Venus. The most notable probably being the efforts by Pioneer Venus 1, which spent 13 years studying the atmosphere and collecting surface data using radar. As we have touched upon, Venus has been subject to fairly regular visits by probes from various nations, and this continues to this day. Currently, the Japanese Akatsuki mission is orbiting Venus. This mission had a troubled history. It's actually arrived later than planned after it failed an orbital insertion maneuver back in 2010. After that, a series of flybys had to be used to reposition it in order to enter orbit in 2015, a task which it accomplished. Now, however, it is active and working through its mission to further study the atmosphere of Venus. At present, the interest in exploring Venus shows no signs of abating. Missions from ESA, NASA and Roscosmos are seeking to build upon the past exploration experience, and the Indian Space Research Organisation have their own plans for atmospheric balloons to add to their growing list of space ambitions. That's about all in our overview of Venus. There's obviously a lot more information out there concerning the different robotic missions that have been sent to Venus. If enough people want it, maybe there will be a separate video about the different probes and what they found out. Let me know in the comments below if that's something you'd like to see. Thanks for watching, and see you next time.